Welcome to a new test and teardown video. This time it's an audio tube amplifier. Look at that. A Philips 2808. It is from 1943. And this one is 30 watts of output power. It is of course a cinema output amplifier. I got two of them, and I also got the two power supplies, and I also got the scope. What a fantastic score. But it is in a terrible state. Let me show you the spiders and the rust and the, I don't know, it's really corroded all over the place. But it looks like we got all the tubes at least, and all the rust that comes with it. It can be a thin little rust on the surface, but it can also be a deep, nasty. Yeah, look at that. All those capacitors for all the different voltages and stuff. Yeah, look at that back there. It looks really bad. I don't know, but I think this big transformer right here, I think this is the output transformer. And I think I got also the two power supplies, and they are more or less the same size, with big hefty rectifiers and all the capacitors and stuff like that. I'll of course show them later on. But first I want to inspect what is going on with the state of this unit. Is there any hope? Is there any chance? And yeah, we got those two beautiful EL51 output power. And they look like they're okay. I will of course pull up all the tubes and do a deeper going inspection. All those will be EF6 tubes. And they made it real nice with shielding and all that here. Ooh, this one, see? It is loose in the glass. So you need to pull them up using a little bit special technique and then glue them. I know how to do that, so that is no big deal. This is how it's supposed to look like when you push them a little bit. But this one I need to be especially careful about. This is the volume, by the way, and it's the potentiometer is fully shielded like that. It's pretty sexy. And even inside here we got a little bit, you can't really see through the glass, but it's also corroded on the inside. If I find it real difficult to speak, it's because I've just been rotating this thing, and it is really heavy. So that will be all the different plug-ins for the power supply from the rack. The idea is you pull these in and out of a rack real fast and easy for service. So that is really one big hefty transformer, and there's a little fuse down there. We got all the different power resistors for all the supply voltages and stuff. There's even a little extra transformer hidden down there, and it looks like this piece of metal here is welded to the bottom. So how can I? No, we got screws, or at least one. So I should be able to pull this out. Oh, good. I was afraid that it's not easy to service, but... And look at the isolated capacitors here. So we got extra wires going to the outside of those capacitors, and this one is completely corroded all the way through the aluminium. Look at that. Oh, it's falling apart. 26.2 kilos for one amplifier. This is how the complete unit looks like before it was transported to my lab. And we can see got an oscilloscope and 2 additional power supply units. I had the idea they were power supply units for the audio amplifiers, but that is definitely not the case. The power amplifiers, they are definitely standalone units. They take mains input as line or very low level inputs, and then they drive a high impedance, high voltage speakers. And the oscilloscope is probably just for checking if there is any ripple or something like that. And of course I got all the different parts and units from this cabinet. Let's look a little bit on the inside. Oh my goodness, that is some fantastic unit. Of course it is in a really, really sad shape. It is really, really old, and it was most likely not stored the best place. See, this switch you can't move at all because it's completely rusted all over the place. And this is a really, really nasty multi-switch for different features, I guess. We just have something that called some numbers. I don't know exactly what that is doing. I don't have any manuals, no schematics, no information whatsoever. I need to figure out everything myself. And back here we got a big hefty transformer again. Small transformers, I think some chokes or inductors, maybe some transformers. Quite a lot of that. And this is some really, really funny, what is this? Over voltage spark, over neon bulb something. Maybe, I don't know. I will have a little look at that. But this is maybe the audio output transformer, right? And it looks like there is a little spider egg collection right there, so I better clean this before they hatch and I get unwanted visitors from, I don't know, whatever planet that is. And also we got some cracked capacitors up here. See, that'll be some of the parts from that capacitor, I guess. Look at that. See, it's falling apart, so we'll see the inner guts of that capacitor. So it's more or less all the parts that needs replacement. And I don't know, maybe those resistors are good. Here's another cracked capacitor. Maybe that one is good. Maybe that, no, look at that. And it's also very, very rusty here. We can also see the bottom plate down there is completely rusted. This is just some isolation material. I was hoping for some schematics, but that is not the case. I'm stuck, I think. So let's play a little bit further with this power amplifier. And I took away the back part of this volume knob. And look at that. It is one of those big, hefty attenuators. I didn't expect that. So I added a little bit of contact 61, and now it actually moves really nice and smooth. So that is great. But look at those switches here. I don't think there's any chance I'll be able to move these at all. I also don't know exactly what they're doing. The marking here on the front says only +B or +H. So what exactly is it they're doing? I got not a big idea. And then I took out the meter because it was really corroded and all that. And you will not be happy to see this. It is really, really bad. It's completely corroded all over the place. But it's actually, see, it is moving. So I guess it is a possibility I can maybe fix it, but it's, as you can see here, not the best. And it's the same, anything I pull out or anything I look at, it just falls apart. Of course I try to clean it a lot using a paintbrush and compressed air, and that really did help. Now we can see the sockets, we can move around here and see how bad it is. I even tried to clean this side of the transformer and add a little bit of paint. I didn't clean it down there, so I didn't paint it, but up here it's really looking nice and fine. So there is hope I can actually make it nice and beautiful, and that is what I wanted to achieve with that test. And there's another little test I just did. The top for those 4 signal tubes. Look at that. I just painted this one, and this one was looking almost as bad as this one. All I have to do is take a little bit of one of those metal brushes and just remove a little bit of this rusty metal, and then hand paint it like that, and then from a distance it's gonna be fine. I will of course paint all 4 of them, but that was just a little tester. And also I'm looking for some paint to so I can clean and fix these little clean this. It's probably gonna be fine as well, but we have much bigger problems, and that will be the different components. So this is one of those many in one capacitor, and all of these, I think there's only one capacitor in each of these, and all of these, they are 16 micro and 32 micro, and they're about 500 volts. I think the bigger one here, they are 450 volts, and those, they will all be 500 volts. And yeah, you have of course already noted this, but I am missing one tube, and this tube is the AX50 as written here at the front. So this is one of those rectifier tubes for the high voltage, and I need that of course to get everything up and running, but it is using, I don't know, I think it's 16 watts just for the filament. So it is a lot of power wasted just for this rectifier tube. So I think I will just use silicon diodes instead of that. So we'll see what comes into that. Also, here we got the anode connectors for the 2 output pentode, the power pentodes. And I believe they're running in a push-pull. So it's a push-pull output stage, and those 2 wires, I can just follow those 2 and see that they go to the output transformer at the bottom. And then I will start to make a little hand schematic, something like that, and then I will just, it's easy to look up the 2 sockets here. You can see somebody changed one of the sockets, and this one is actually cracked, and the other one is good and fine. So yeah, somebody changed this one, and it's the plastic at the bottom here is not as good as the original type. So that is also a thing to worry about. And of course the isolation, as you can see here, that will be the cathode side, the low voltage side. So it's okay with this thin piece of paper, because that is low voltage to chassis. I also noted some other little details about the tops for those 4 tubes. As you can see, there's a connection inside here that connects to the tube, and then the outer part, the metal here, is connected to a shield. But on these 2, that shield is directly connected to chassis metal. But here they are isolated, and they're not connected to chassis metal. No, they're connected to something else. And I think this will be the input amplifier, and this will be the next driver stage or something like that. I haven't yet figured out if this is true, or they are high or low voltage push-pull driving the output stage tubes. I haven't yet figured this out, but that is definitely something I need to understand, at least how the signals go and what is going on. I also need to figure out what those switches actually do, and also what is this switch doing with all those many different settings. I don't even know what this one is doing. So yeah, there's a long way to go here. I keep finding more and more funny things in this unit. So this is a big hefty neon bulb, and it's mounted on one of the windings on the output transformer. I bet there is a special tapping for this, because this tapping, this one here, is not used for anything else. Or maybe this winding is just by luck not used, because it's the different ohms of loudspeaker tappings here, I guess. And so this is probably just an over voltage or overloading protection of some sort. But why is it this burned to pieces? That is one big mystery. So that means this probably lights up every time there's a clipping to avoid the over voltage spark over everywhere, right? But look at that, it's completely dark. And I tried to give it a little bit of high voltage, and yes, I can see tiny little glimpse of neon color shines up a little bit in here. And it's called Philips, and then 4378, and then A13, if that matters. I know it's difficult to understand, but I realized I need to be able to understand exactly how this amplifier works to be able to repair it and get it up and running, because everywhere I look, everything is just defective. And so I'm poking around with everything and unpacking all the cables, because as you can see here, all the cables, they are packed into this paper sticky stuff. And this, you can actually see it a little bit here. It falls apart quite easily, so that's good. And it prevents me from following wires and connections. And I am a little bit tired of walking around with my own meter and trying to figure out how stuff is connected. And because everything changes color every time they solder something, look at this. They solder a wire to a point here, and then they just continue with another color. And this is just something. Here's a brown wire we soldered to this, but let's take a yellow. And so forward, actually everywhere we go. And they got maybe those 4 or 5 different colors of wires, and everything is just made with these in one random mess without any kind of intelligent life or energy to it. So this is driving me a little bit nuts. But I got a lot of breakthroughs in all this. I figured out the different transformers and what is in and what is out and what is connected to this and to that. We got the speaker output here, and I just took one end of the speaker output and I call this 0. So the next one is speaker 31 for 31 ohms DC. And that is a big worry because that means if the DC output resistance is 31 ohms, this system is for very high impedance speakers. That is a little bit of a project killer, to be honest. But we got some other windings, and there is probably a way to cobble this in a little bit different way. Well, I also found a separate winding. I call this a feedback winding, and it is on both of the inductor packs here in the transformer, and this is a usual way to make it because it's an audio output transformer. We also see the 2 anodes here from the 2 output power tubes, They go via resistors, and then they drive each side of this pull-pull, so it's definitely a push-pull system. And the center tapping of this primary system, it's running in a single wire like this, and it goes to a little fuse up here that is directly connected to the transformer. And this is because the other end of this high voltage stuff, of course, goes to this rectifier tube, the high voltage side, and it doesn't really matter what side it is that makes the DC is one side or the other one. This is actually a little bit funny, but that's just how it is. And of course there is another wire from this center point that goes to all the capacitors. But anyway, the two wires here from the audio output transformer goes of course to the feedback system. And I just marked those two wires here, feedback brown and yellow. And all those resistors we see down here, they are of course in the cathode system of the two driver tubes. And that is actually the output amplifier section. And then we of course got the input amplifier system with the two first tubes. And they make an output using the two input transformers here. So one input transformer is for the first tube, and the next transformer here is driving the two tubes right here in differential mode due to this transformer. And the input to this transformer is this red wire we see right here. And the idea about putting this in and out of the connector system is of course so you can parallel more amplifiers or have them much more versatile setup for in the rack systems and all that kind of stuff. So that is of course what we need to do, is to connect the inputs and the outputs here. We got the speaker, we got the mains voltage and all that kind of stuff. So I'm trying to figure this out. I don't want this end panel here. I want to remove this and put in my own little panel here with my own connectors and all that. And assuming I have a way to figure out the output impedance, I will of course go and pick up the other transformer from my other unit and double check it is exactly the same, because what if this one is actually broken? But I will in a few minutes I will put in some signals here on the two anode sides in differential mode, and then I will see that all the different voltages and stuff here and phases is correctly nice and fine. This will help me to figure this out. So I've been searching around for all the diodes, and finally I found them. They were mounted down here in these two holes here, so they were totally hidden. And this is a completely rusty, crusty selenium rectifier. And I will, of course, I have to desolder everything here and measure everything and see if there's just a little bit of diode left in all those totally shorted, blown up parts here. And this will help me a little bit. Oh yeah, about the extra winding here. There's a low voltage output from the transformer that goes via the other two wires we see here, the gray and the red. And they go actually to a little rectifier here, and to a little resistor and to a capacitor, and this is driving the meter. So in one of the settings with this knob we have here on the front is of course the output voltage swing via this diode rectifier system. And also I believe the different settings here, I haven't yet figured this out completely, but this is a very, very complicated way they have done all these things. But this is involving biasing and high voltages and cathode voltages and all sorts of things in this entire amplifier. So I believe maybe we can route the meter to measure anode voltage, cathode voltages and stuff like that, but it can also turn on and off different biasing and all that. It's really, really complicated, and I have so many loose connections in this switch as well. I also found the fuse to be completely broken. There's nothing to do here, and this is the power on bulb, which is also causing me a little bit of a problem. I don't know if we can see the See down here, it's almost touching some other metal parts down there. In the distance down there, we got this resistor right here that's completely blown up. I got quite a lot of those red resistors, by the way. We see them here and there and everywhere, those Phillips resistors. I got a few of them down here in this cathode system. We got two cathode systems that is exactly the same for the two push-pull driver tubes we have down here, and good luck. The values they're actually written on the resistors, although they are mega ohms, but the text is 150 ohms and 10 ohms, but mega ohms when you measure them. And this is of course why nothing here is working in the driver section. Yeah, I'm still trying to figure out the preamplifiers and the feedback and the cathodes here, but because I think I really need to understand this as well, because we got all those blown up parts and blown up capacitors and whatnot. So yeah, I am forced to make a much more detailed schematic. Yeah, otherwise I'm not able to understand what is going on. Damn it. Still working super hard with this unit. So I took out the output transformer to do a little bit of investigations and rewire the different tap hangs and all that. But I'm still going with the 31 ohm DC resistance secondary winding. I don't think that is the right one for my usage. We got some other tappings and I'm doing a little bit of investigation. But before I go and play with all that, I'm also measuring on the feedback winding for that. And here we got the push-pull transformer. This is the push-pull tube input to the transformer, and my audio output is here. So let's look at the frequency response. And remember, this is there's no feedback, there's no closed loop or anything like that. So we're just looking at a 1 kilohertz input and output and all that. We've got 10 volts per division up here, of course, and 5 volts per division at the output. So it's only half of the voltage, and that is, of course, super crazy high. So that will be some really high impedance, high voltage speakers used for this system back in 1943. So this is very close to unusable today. So let's play a little bit with the frequency. Note the amplitudes. So this is 1 kilohertz. Let's go down to 100 hertz like that. And what do you know? This is very close to the same amplitude, isn't it? All right, so let's go down further, down to 10 hertz. How about that? So that is some crazy frequency range. Okay, so let's change it to 10 kilohertz. And here is 10 kilo. Let me zoom in. You can see it's a little bit, but it's, I mean, it's very close to the same. Okay, let's just dial in the kilohertz. See, there's a little bit of a peak right here at 20. And okay, let's go find where the peak is. 23 kilohertz. And this has something to do with the impedance I'm loading with. I'm using at the moment two 27 kilo ohm resistors on the two plate. I'm simulating the tubes actually. So I think those resistors need to be a little bit lower than this, and then it's probably gonna go weigh this little resonance. But we really don't care that much because this is way over the frequency range for this unit anyway. I'm just trying to show how cool this output transformer really is. I'm quite happy about it. So now I will just polish it and wash it a little bit and try and paint it real nice and shiny and see if I can get it real beautiful again. And then I got the other much lower impedance outputs, and yeah, I'll probably go and rewire it for low impedance outputs to drive a modern loudspeakers. That is my idea, at least. After a lot of different experiments using different couplings, I actually found a very low output impedance mode on the secondary. There's like a ton of different ways you can connect and couple the secondaries. But anyway, hear me out. Let's see if this is working. At the moment, I'm using a 10 volts peak. So this is 20 volts peak. The input is where is it? Here is it. So the input is 7 volts RMS. Okay, so this is my input. Okay, so let's just take the 20 volts signal. The peak voltage is 10, and if I have a 500 volts supply, and this is my maximum for my tubes, that means 25 times as much voltage potential. So that means I should take my output RMS 0.8 volts, multiply by 25. Okay, then I get 20 volt RMS. Okay, so 20 volt RMS divided by 8 ohms is 2.5 amps. Then the 2.5 amps and the 20 volts. This will give me a maximum potential of 50 watts, assuming I'm running at 500 volts. So this is what I'm going to go with, and let's see if this turns out to be good. It's a really thin wire, by the way. But of course, this whole system was initially designed to be used with old cinema speakers back in 1943. Output impedances was like really high. So that is probably why we have these thin wires, and it was of course coupled for very high output voltage and very high output impedance. I think we have what some might call a showstopper, because of course the output impedance of these transformers is of course relevant too. So here's a DC ohm meter, and let's check the output winding copper resistance is 6.5 ohms. So that means no matter what with the I fixed the voltage ratios and all that kind of stuff, and this is the lowest usable, and the 6.5 ohms in series with my signal. That is actually what this means, right? So let's take this is of course the old one. Let's take a more modern one, and here is a big hefty one from a well-known brand. And this one is very similar in specifications. We also got a lot of output loudspeaker tappings, and we again got this push-pull system with a sensor tap and all this, and it's for the same about the same voltage and all these kinds of things. It's more or less the same. So I could probably use this one. So let's try and measure what is the DC resistance on the loudspeaker output, and I made this really nice and easy to understand what is going on here. So this is the common, and let's just go for the 8 ohm. Look at that, 0.6 ohms. And if I take these two together here, they say it says 0.1. Okay, so it's about a half an ohm. Oh, let's see, here we go. Yeah, to the 8 ohm output. Let's take the 16 ohm. This is for loudspeakers with 16 ohms impedance. 0.7 is what it's going to be, right? And this is the DC resistance in the copper winding, and this is why this one is capable of controlling the speaker and actually driving the speaker, while the one I got in my Philips amplifier is just too high serious resistance for anything at all. I mean, I can really not use this. And that is, yeah, I think it is a showstopper for now. The problem is I only got one of the triad one, so maybe if I could get another one. But of course I can use this one just to get everything else up and running. Proof I got the schematic working. Proof that I got anything else working. Oh, by the way, we got the feedback windings here, and that is a problem. So I think I should definitely just try and proceed with this one. I will not be able to play full power, but of course low level is of course possible. Then it doesn't matter that much. I lose a lot of output power, and then I can get the feedback up and running. I can continue making my schematics. See, I even painted this transformer and make it really nice and fine for my little refurbish project. I mean, it's fun to think about. This is 82 years old or something like that, right? But now it's nice and beautiful.